Now let's see curve driven pattern. As name suggests, the pattern is driven by following the curve. These tools allow you to create pattern along the planar or 3D curve. Just look at this figure. Now here around the belt we have a curve, right? And we are going to pattern these features, and this will be our outcome. Here this curve is followed. To define the pattern, you can use any sketch segment or edge of face, both of solid or surface body, that lies along the plane. You can base your pattern on any open curve or on a closed curve such as circle. Now it is available in Feature Command Manager under the pattern. So here it is curve driven pattern. Now when you invoke the curve driven pattern command in its property manager, you have to select the first sketch or face. Then you have to enter the number of instances you want, and also you have to define the spacing. Either you tick the equal spacing or you give your custom distance. Now what is important thing is in this curve driven pattern is curve method and alignment method. For the 99% of the curve driven pattern, we are going to use offset curve and tangent curve combinations. Now let's understand the meaning of transform curve and offset curve. Alignment method is very self-explanatory. The outcome will be remain tangent to the curve, or maybe they are aligned with the seed. Now transform curve, let me explain through example. Let's say this is your curve and this is your origin, y and x, just for explanations. Now here I have a feature and this is its center point. Now SolidWorks know what is this x distance, that is called delta x, and delta y distance with respect to origin of this curve. So transform curve will maintain this distance while placing the instance of pattern along the curve. When you choose this transform curve options with the align methods, sometimes you'll find that triangle is not oriented in our case as we want, but the purpose is to maintain, let's say here we have x, y is over here and x is, so it try to maintain delta x and delta y as with the seed features. So distance will remain same for each one. So here you'll find that the outcome is not like a normal pattern. So when the transform curve radio button is selected, the delta x and delta y distance between the parent feature and the origin of the curve are maintained by the pattern instances. We'll see through example. Now in case of offset curve, which is very simple, let's say again we have a curve here and we have a rectangle features. So this offset distance will be maintained throughout all the instances. It is not going to change. So this is a proper outcome of a curve driven pattern. That's why I told you that 99% cases we are going to have the use of this offset curve and the alignment methods. So here when the offset curve radio button is selected, the normal distance between the parent feature and the origin of the curve is maintained by pattern instances. Now in exercise 6.11, we are going to explore all these four options, that is curve method options of transform curve and offset curve, along with the alignment method called tangent and the align to the seeds. So here in this figure, what we are going to do is in exercise, we are going to pattern this feature along the curve and try to see what are the outcomes with the combination of these four options. Now open the file called 6.11 curve driven pattern. Now rotate and try to locate this rectangle feature. Here we have on design manager tree, we have boss extrude 1 and boss extrude 4. We'll try to pattern this boss extrude 4 along this edge. Now I have already created a sketch for you, so make it visible. Now see, the sketch is simply aligned with the edges of the features, and I have created using the convert entities. Now let's try the curve driven pattern. Now here I need to select the curve. So because curve have various segments, so instead of selecting individual segment, go over here and select the sketch 11. Now immediately SolidWorks switch to the features and faces selection box. Here I am going to select this one. Now at this moment I'll choose equal spacing and increase the number of instances. So what SolidWorks do, it simply find the length of a curve and try to place the number of instances by equal distance. As you increase them, the distance between them will reduce. It is but obvious. So let's make it 20. Now here, under the curve method, I have transform curve selection. So let's go at first the offset curve and the tangent to curve options. So these are the most widely used combinations. So offset curve does simply it maintain the offset distance from the curve to the features. And second, alignment method means what? Tangent to the curve. So outcome will remain tangent to the curve. So this is overall outcome of these two combinations. Now if I choose align to shade, look at the preview. All the instances will have a same orientation that we seed have. So if you want this kind of outcome, then you have to choose the align to seed alignment method. But in most of the cases, we'll have a tangent to curve combinations. Now go ahead and click OK. So this way, using curve, you can create a pattern. Now rotate the model and turn on the sketch display. Also roll back the boss extrude feature. So you can see that small feature. Now let's pattern along this curve. So go ahead and click on curve driven pattern tool. Now under the direction, I have to select the curve. So go over here and select the sketch 3. So by selecting this way, you are going to select all the segment of a sketch at a time. Now select these features. Now I do not want pattern in this direction. So click small arrow. It will flip the pattern direction. At this time, I am going to choose first these things, offset curve and tangent to curve alignment method. Now let's reduce the number of instances. Because offset curve option is selected, this offset distance from the curve is maintained throughout the all instances. The moment I switch to transform curve, look at the outcome. It completely shifted from outside to inside. So here, from the origin of this curve, delta x and delta y distance is maintained throughout the all instances with respect to this origin point. That's why to maintain it, that orientation and the location has shifted. So this is very, very typical method. So as I said earlier, if you require this kind of outcome where the coordinates from with respect to origin need to be maintained for individual instances, then this is the only options. But in most of the cases, we will use offset curve, right? You can also go ahead and try align seed method. Now here I have turned this geometry into construction geometry, right? So go ahead and click OK. Now here, let's go and edit that part. Now let's edit the sketch 3 again. Here I will turn the remaining construction geometry into solid geometry and exit. So moment I did, the pattern updates. It choose the sketch 3 and distribute the pattern. Now let's go ahead and edit the pattern again. Instead, this time I will choose tangent to curve. So look at that, all the instances are having tangency with respect to the curve. Now rest of the option in pattern are similar to what we learned in circular pattern as well as in linear pattern. Light selection of bodies, skip instances, geometric pattern, and so. Now in exercise 6.12, we are going to explore the option called face normal. Here the 3D curve is helix. We want to pattern these features in helical way. But here we need to tell the SolidWorks through the property manager that this is the face to which we need to keep these instances normal. So let's try to explore it. Now open 6.12 curve driven pattern face to normal part file. Now on the part file we have a helix and one feature. So go ahead and invoke the curve driven pattern. Here I will choose this helix as a curve and I will choose this feature, but I have to select the face normal, so I have to choose this cylindrical face. So look at that, how it is going to place. Now let's make this option tangent to curve. Make sure the proper curve method and align method is selected. Now you can increase the number of instances required. It's depend your choice. So with the option called face to normal, every instances will remain normal to the selected face. And go ahead and click OK. So if you want to create a pattern, a spiral pattern, then you have to use that options. Now let's learn the fill pattern through example. You might have seen the sheet metal having perforations. You can also observe same thing in PC cabinet. So such small holes are provided for the ventilations. So typical use of fill pattern include weight reductions, ventilation, and for grip surfaces. So fill pattern simply fill the defined region with a pattern of feature or predefined cut shape. So you can add the material or you can remove the material, but simply filling in the selected regions. If you use the sketch for the boundary within which you want to fill the pattern, you additionally require direction to place the pattern. Now under the fill property manager, you have 4 options. One is perforation, second is circular, square, polygon, under which you can control the distance between 2 row, inclinations, and the gap from the boundary. You can also validate the count. What does it mean? Means these all instances which are fall under the regions, sometimes some based on the pattern it may cross the boundary. So that boundary which is fill up from the surface will not be counted as a valid count. So with the help of this you can consider how many holes or the pattern will be fall inside the selected regions. So this is very helpful. So let's try to explore this fill pattern. Now in 6.12 exercise, what we are going to do, first we are going to fill the pattern on selected face. So this will be our outcome. Secondly, we are going to fill inside the selected sketch, and probably this is going to be our outcome. In 6.13, we will use seed cut features which offer ready-made available shape. So we can remove the material. We can create a perforation shape. So either we'll use the square of 3 mm and or maybe the circular shape or polygon with the perforation pattern and polygon pattern. Now open the file 6.12 fill pattern curve underscore directions. Here I have a small circular features which I want to pattern using fill pattern options on top surface. So go ahead and select the fill pattern. Now here under the fill boundary selection box, I will choose this top surface instead of this curve. So let's select this top surface. Switch to the feature selection box and select this. Now look at SolidWorks has started filling the pattern. Now the first pattern layout is perforations. Second is circular. Third is square, and last is polygon. Here you can control the spacing between them. Now when you click on validate count, it says fail to validate instance count. Reason is because we have choose this surface. This works well when we create fill pattern inside the curve. Now let's change the pattern to circular. So this will be work as a center, and these are the diameters. Look at their pattern. It is flowing in this manner. If you want to change the distance, you can change the distance. Let's say 20. So distance between them will change. If you want to control the offset distance, then add. So from the edge, it leave that much space and fill the pattern. And make this offset distance to 0. And change the pattern layout of your choice. Go ahead and click OK. So this way we can simply use the feature to fill the surface. Delete this pattern we have created. Again, go to fill pattern. This time under the fill boundary, I will choose this curve. And under the feature selection box, I will choose these features. Now here, I do have to provide the directions. So this, because it is sketch, I have to provide a direction. So this is my directions. If it is surface, it does not require the selection of directions. But because we are filling inside the 2D sketch, we need to provide the directions. You can change the directions. Now choose a proper pattern layout. Now here, let's try to click on validate count. So here exactly we have 23 instances falling inside this curve. If we increase the distance, let's try to increase the distance. Because the region is decided, it is fixed, the number of instances decreases because we have increased the dimension between them. Now let's reduce to 5. So more number of instances are covered. So go ahead and click and validate. So this way, by changing the number of distance, we can change the number of instances falling inside the curve. Now with the help of this validate count, you will have an idea how many features you are going to place. So some calculation can be done based on this number. Click OK. So this way you can use feature to fill the pattern. Now open the file 6.13. Go ahead and invoke the fill pattern. Now choose the surface. In this case, it is top surface. Now what we want to do here is we want to create perforation. That means we want to remove the material. Now for that, under the feature and faces, we need to select create seed cut. So moment I do that, I'll have a 4 shape. One is polygon, diamond, square, and circle. So let's select the circle. Now here the diameter is also provided. Let's make it 5. Now here let's select the center. So this will be our center, and from that the distance is centered, right? So this is our origin, and every circular pattern is going to place in this direction. We can also change the directions. Look at this. Let me take it very close. If I change this, what will happen? Look at this. So it is cutting above the surface. Actually, there is no material over there. So at this moment, we cannot use this option fill shape directions. So untick it. So obviously it is going to remove from the material. Go ahead and click OK. So this way instead of creating these holes, you can use fill pattern, and under that you can use seed cut features. Now let's go ahead and edit this pattern. Now this time I will choose square. Now here you can also change the direction. Look at that, when I increase the angle, it changes direction from horizontal direction, considering the horizontal direction, and orientation towards anti-clockwise direction. You can also control overall dimensions of these seed features. So you can choose any shape you want, right? Under the polygon, you can reduce the number of sides. And this is the diameter's value change, right? That is circumscribe and inscribe circle, as we understood in sketch pattern. So this is what all about fill pattern. You can create the cut in the surfaces. Mirror simply create a copy of one or more features mirrored about a face or a plane. So don't think that only one feature can be mirrored. You can select multiple features. They can be mirrored about a face or plane. Now what's an advantage? It basically create a copy, so it speed up the design process. And also if you modify the original features, its mirrored copy get updated to reflect the changes. This is the benefit. So in parts, you can mirror faces, features, and bodies. But if you are in assembly, then you can mirror the assembly features. We'll see all this when we learn in the assembly module. Now here in this figure, we have one circular features which is get mirrored on a right side. Now these two get mirrored over here as well as on a left side and right side. The mirror property manager will ask you to select the face or plane. You can also select the secondary plane, which is normal to the previous one. Then under the selection of feature, select the feature you want to mirror, or either you select the bodies you want to mirror. If you are working in surface modeling, then you have to choose the faces to mirror. Now rest of the options are same as we have explored earlier. Through exercise 6.14, we will explore how to use mirror to create a mirror copy of a features efficiently. So you can draw this sketch which have a square shape of 100 by 20, 100 by 20. And then we are going to create this triangular shape, and we'll add these features and try to create a feature around all these four corners. Now create a sketch as given in the slides, or just open the file called 6.14 mirror_example. Now here we have extrude feature 1 and 3. Now I want to mirror these features on right side. So for that I required a plane over here. Now I assume that I have drawn the first features little bit offset, so I need to create a new plane. So I will go to the reference geometry and click on plane. So choose the first reference and second reference. So SolidWorks automatically will create a middle plane. Click OK. Now let's go to the mirror feature. Now choose this newly created plane. Now here I want to select the feature to mirror. So select this triangular shape and click OK. So using that options, I'm able to mirror that feature on a right side. Delete the feature we have created and also delete the plane we have created. Now because the front plane exactly in the middle, I will use default plane to do the mirror of a same features. Again, let's go ahead, mirror, and select the front plane because it is exactly at the middle. Now choose these features. Now let's see the top plane is also at the middle of a horizontal part features. Under that, under the secondary mirror face and plane, I will choose top plane. So what it does, it's take these features and mirror it. Also mirror the seed feature at the bottom side with respect to this horizontal plane, along with the patterning or mirroring of these features, instance features. Click OK. So with the single mirror feature, I am able to mirror triangular feature across the four corners. Now go ahead and click on edit. Now instead of creating the mirror copy of an instance, I only want to mirror these features on this side and this side. That means I want to only create a mirror copy of a seed only. So choose over here. So these get mirror over here and these get mirror over here. So additional copy, which is a mirror copy of a instances, is not displayed. So if this is what you want, then you have to choose this mirror seed only. So mirror command, it is very simple command. All you require is mirror plane. Now we will practice the mirror command through this exercise 6.15. I have also provided you solution file in resource folder. But I want you to try yourself to build this entire model. So it will strengthen your concept of mirror, extrude cut and sketching. Open the new part file. Make sure the unit are in inch because our exercise is in inch. Now on top plane, I will start rectangle. Vertical it is 3.5 and horizontal it is 4.250 and click OK. So extrude that part. Now thickness is given 0.750 and right click. Here the dimensions are given in with the 3 digit of precision. So let's go ahead and change that to 3. So click on edit and under the length select .123 and click OK. Now if we wish, we can include the fillet inside the sketch. So let's go ahead and do it. So edit the sketch, select the fillet and the value is 0.250. Okay, and I will choose all these four corners. Right click and exit. Because we can also use to create a fillet using fillet features, but we haven't explored yet. That's why I cover the sketch fillet. Now on this face, open a new sketch. Now let's first draw center line. And draw rectangle. And let's make it symmetric about center line. Press Ctrl and select all of this line. Go ahead and select symmetric. Now let's give the dimensions. It is 4.25. So from here it is 4.25. And width is 1.75. And let's extrude it. Now extrusion is towards inside and it is 0.5. Now let's add from the back side a circle. So here from this to this, again another circle whose diameter is 1. So this is 1. Now let's extrude the outward as given in the sketch. It is 0.75. So I will choose this largest circle and the distance is 0.75. Now again, I will reuse that sketch to create extrude cut. I will expand this contour selection and I will choose the smaller circle. And I'll go to the depth that is given is 0.75. I could have added the fillet over here, right? But I will use this time fillet feature. So you can have some basic experience how to use it. The value is 0.5. Use these constant fillet options and choose this edge and choose this edge. Use full preview so you can see what's going on. Select OK. Press Ctrl 7 to orient the model. It's time to mirror this vertical feature. Now the problem is the front plane is not in center because I deliberately made a mistake while creating this sketch of a base features. If I use the center rectangle, then this front plane will be available at the middle location. So let's go ahead and create a new plane. So we'll select this surface and select this surface and right click OK. So we have a middle plane because we always require it for mirror feature. Select the newly created plane and invoke the mirror features, or either you start the mirror feature and select the plane. Now here I have to select the features. So I will use this fillet features, these features and this one. Clear? And go ahead and click OK. Now see, something is left out. So let's edit the features and let's add the cut features. Earlier we have only 3. So make sure you do not forget to add the number of features you want to mirror. Click OK. And hide the plane. Now let's create 5 holes. So select the top surface and click OK. So let's create circle over here whose diameter is 0.5. Now it is also located as given horizontally 0.5 as well as from top edge it is 0.5. Now let's click Feature Manager and activate the Extrude Cut. Make sure Through All is selected. So we have added one hole. Now we know we have a front newly created plane, but we want to mirror this hole on all the 4 sides. Either it can be over here using the plane 1, but if you have an additional plane, then we can add same thing at a time on this side as well. So let's create one more reference plane. Now let's create one more reference plane. Select this surface and select this surface. So automatically SolidWorks created a new plane 2 exactly at the middle. Now click on mirror feature. Select this plane, select this secondary plane. If you're not able to select it, then expand this and select from here. So 2 planes are selected. Now this time I want to select this hole. So look at the outcome. So using plane 1, it get mirrored over here, and using plane 2 both get mirrored over here. Go ahead and click OK. Turn off the display of these two plane. Now only one thing is remain is the center hole. Now only thing remain is center hole. So go ahead and select the point under the reference geometry and choose the center of a face. Let's see what happened. It exactly find the center of a face and click OK. So we'll create a new sketch and we'll use this point as a reference. And diameter is equal to the all these 4. So let's make this, select this and control this and make them equal. Now it is fully defined. Go ahead and create extrude cut. Make sure it is through all and select OK. So this way, using mirror feature, you can mirror the created feature of a part. You can also use reference geometry depending upon the complexity of a part.